Hello everyone, I am Nandini, Department of CSEI from Sri Venkateswara College of Engineering, Bangalore. Today I am back with an interesting topic that is operating system structure. First, let us know what is an operating system structures. The interconnections between the various operating system components can be defined as the operating system structure. The operating system is divided into various different structural types like simple structure, monolithic approach, layered approach, microkernels, exokernels, and virtual machines. An operating system is a construct that allows the user application programs to interact with the system hardware. Since the operating system is such a complex structure, it should be created with utmost care so it can be used and modified easily. An easy way to do this is to create the operating system in parts. Each of these parts should be well defined with clear input, output, and functions. And next, when we come to the operating system structure in modern computing technology, first one is cloud computing. Cloud computing relies heavily on the operating system structure to manage resources and provide a seamless experience for users. The operating system provides the necessary abstraction layers to allow cloud providers to offer virtual servers, storage, and other resources to customers. This allows customers to access resources on demand and pay only for what they use. Next is a virtualization. Virtualization is another technology that relies heavily on the operating system structure by providing an abstracting layer between the hardware and software. Virtualization allows multiple operating systems to run on a single physical machine. This allows for greater efficiency and flexibility in resource management as well as easier maintenance and upgrades. The operating system structure operations are, let us see one by one. Kernel. The kernel is a core of operating system that provides basic services for all other parts of the system. It manages the system resources such as CPU, memory, and input and output devices. Next is the device drivers. Device drivers are software components that allows the operating system to communicate with hardware devices such as printers and network adapters that translate hardware specific commands into language that the operating system can understand. Next is the system libraries. A system libraries are a collection of pre-written code that provides common function and services to applications. They include functions for input, output, memory management, and networking. Next is a shell. The shell is a command line interface that allows user to interact with the operating system by typing commands. It provides a way to navigate the file system, launch application, and perform various system tasks. And process management. Process management is a key component of operating system structure that involves the managing the execution of multiple processes on a single CPU. This includes scheduling processes, allocating resources, and handling inter-process communication. And memory management. Memory management is another important aspect of operating system structure that involves managing the allocation and deallocation of memory to processes. This includes virtual memory management, which allows processors to use more memory than is physically available by swapping data and from disk. And file systems. File systems are the means by which an operating system manages and organizes data on a storage device. This includes managing files and directories, providing access control, and handling disk errors. The last is the system calls. System calls provide a way for application to interact with the operating system. There are applications to request services such as opening files, creating processes, and allocating the memory. The structures of the operating system are simple structure, monolithic structure, layered approach structure, microkernel structure, exokernel structure, and virtual machine. First, let us see what is a simple structure. It's a most straightforward operating system structure, but it lacks definition and is only appropriate for usage with tiny and restricted system. Since the interfaces and degrees of functionality in this structure are clearly defined, programs are able to access input routines, which may result in unauthorized access to input procedures. And next is a monolithic structure. The monolithic operating system controls all aspects of the operating system operation, including file management, memory management, device management, and operational operations. And layer structure. The operating system is separated into layers or levels in this kind of arrangement. Layer 0 is the lowermost layer, contains the hardware, and the layer 1 is the highermost layer, contains the user interface. These layers are organized hierarchically with top level layers making use of capabilities of the level ones. And microkernel structure. The operating system is created using a microkernel framework that strips the kernel of any unnecessary parts. System and user applications are used to implement these optional kernel components. So microkernels is a name given to the system that have been developed. Next is a exokernel. An operating system called exokernel was created at MIT with the goal of offering application level management of hardware resources. The exokernel architecture's goal is to enable application specific customization by separating resource management from the protection. And exokernel size tends to minimal due to its limited operability. And the last one is the virtual machines. The hardware of our personal computer, including the CPU, disk drives, RAM, and network interface card, is abstracted by a virtual machine into a variety of various execution contexts based on our needs, giving us the impression that each execution environment is a separate computer. Virtual box is an example of it. And the types of operating system. There are several types of operating system. They are batch operating system, multi-programming system, multi-processing system, multitasking operating system, time-sharing operating system, distributed operating system, network operating system, and real-time operating system. Batch operating system. This type of operating system does not interact with the computer directly. There is an operator which takes similar jobs having the same requirement and groups them into batches. It's a responsibility of the operator to sort jobs with similar needs. And next is a multi-programming operating system. The multi-programming operating system can be simply illustrated as more than one program is present in the main memory and any of them can be kept in execution. This is basically used for better execution of resources. And multiprogramming operating system. Multiprogramming operating system is a type of operating system in which more than one CPU is used for execution of resources. It betters the throughput of the system. Multitasking operating system. Multitasking operating system is simply a multi-programming operating system with having facility of round-robin scheduling algorithm. It can run multiple programs simultaneously. Time-sharing operating systems. Each task is given some time to execute so that all tasks work smoothly. Each user get the time of the CPU as they use a single system. And distributed operating system. This type of operating system is a recent advancement in a world of computer technology and are being widely accepted all over the world, and that too at a great pace. Various autonomous interconnected computers communicate with each other. And next is a network operating system. These systems run on a server and provide capability to manage data, users, groups, securities, applications, and other networking function. Real-time operating system. These types of operating system serve real-time systems. The time interval required to process and respond to input inputs is very small. This time interval, real-time systems are used when there are real-time requirements that too very strict, like missile systems, air traffic control system, and robots, etc. And let us see some of the responsibilities of the operating system. It controls all the computer resources, and it provides valuable services to user programs, and it coordinates the execution of user programs, and it provides resources for programs. It provides an interface and virtual machine to the user. And some of the functions of operating system are memory management, processor management, device management, file management, user interface or command interpreter, booting the computer, and security, control over system performance, job accounting, and error detecting aids, coordination between other software and users, perform basic computer tasks, and network management. Thank you for watching. Please do like, share, and subscribe the video, and we'll see you in the next video.